Okay, I want to move on to the Bics system. Bics, B-I-C-S, stands for Bobcat Interlock Control System. Now the valve we've been dealing with, this cutaway version, uh, it's actually quite an old casting in that it was never designed to have any additional external safety systems built into it, like this more modern valve I've got here. Still an older valve, but a generation after this, where another manifold was added to the valve body to make the machine safer. So this is to protect the operator, especially when entering and exiting the machine with the engine running. So we're going to have a look at the Bics, or the Bobcat interlock control system here. So I'm just taking the bolts out. I've got the bolts loose, but you notice on this valve there's mounting holes and fasteners. There's a valve body that comes loose from the main valve here, whereas this one has no threads to install a Bics system. And we'll also notice that on this one, the work ports for all the functions are threaded. You can see how they've got a recess here for an O-ring, so they take an O-ring boss or straight thread O-ring adapter that would connect to the hoses. On this more modern valve, when I take the Bics system off, we can see it's got a mounting surface here that's designed to mate up with some O-rings. So the valve body is basically the main lift, tilt, and auxiliary valve is basically the same layout and design and same casting, but the main modification is that instead of threads now, we have O-rings on this surface, a little more material here, and we've got the threaded locations for the Bics manifold to install. So when the Bics goes on here, it bolts on, and it covers, when the Bics system goes on, the Bics has sort of four main ports that cover these four work ports. So here's our lift spool again. Here's our inlet, main relief here. So we're going lift, tilt, auxiliary. Well, the Bics manifold comes on and covers the work ports for lift and the work ports for tilt. It does not cover the work ports for auxiliary. The Bics manifold really has nothing to do with auxiliary. So auxiliary on the earlier valve body and on this valve body is going to function identically. Because it was always electro-hydraulically controlled, we didn't need an extra manifold for auxiliary to make it safer. But we'll see with lift and tilt, especially with pedal linkage, there was a need to have some blocking of the work ports, the engineers thought, to make this valve make the machine safer to enter and exit with the engine running, especially. So this valve, although it's a little newer, still this version is just mechanically operated. You can see the linkage pins for lift and tilt. So imagine if you've got the front door open on a Bobcat skid steer loader, you're going to be climbing over the loader frame and bucket or whatever implements on it to enter the cab of the machine, which you can do, and it's safe to do with the engine running because of the Bics system. But if you're going to step in where pedal linkage is, you're going to be putting your feet down right where the pedals are that operate the lift and tilt functions while you're climbing in. And of course, if the loader frame was to raise or move, there's no clearance for a person between the loader frame going up and the entrance to the cab. So that's where the Bics system comes in. So in the literature that goes with this, they're pointing out the Bics valve. So the Bics valve is this body that's mounted on top here. You can see there's a Bics solenoid that's mounted to a valve that kind of turns on and off the Bics functionality. And we'll look at how that operates. So there's an electrical connection. Again, looking at the auxiliary back here, you can see that the Bics valve doesn't cover the work ports for auxiliary. Auxiliary was already electrically controlled, so no need to add Bics to the auxiliary. But now we're putting a solenoid on the lift and tilt that's going to be able to force the opening or blocking of work ports based on the position of a seat bar and a signal from a press to operate switch inside the cab. So summary of how this is going to work: if the operator enters the cab, puts the seat bar down, hits the press to operate button, this solenoid will then be energized, and this solenoid will open up the Bics system and allow oil to come and go from the lift and tilt circuits. But if the operator doesn't do that, if they aren't in the seat of the machine, or the seat bar isn't down, well, they don't have to be in the seat. That should be clarified too. It's a case of the seat bar being down and press to operate button being pushed. Now, if an operator wanted to make the scenario dangerous, they could reach in the cab, put the seat bar down, hit the press to operate button, and implements could move. So some training still involved here, but yeah, that's in a nutshell how the Bics system works. Now, pre-Bics, there was a manifold that would go on the valve here, and machines with Bics as well. If you've got mechanical linkage, there's an extra manifold that goes on the valve, and there's two solenoids that will stop the motion of the lift and tilt spool from moving out of the neutral or hold position. So the Bics, along with what they call spool lock solenoids that would install here, instead of just having these rubber boots, there'd be an extra manifold and two spool lock solenoids that really should be installed on this valve. But that sort of gives you what you might think of as belt and suspenders kind of safety on the implement movement. Then you've got two things that have to happen. If one system were to fail, you've kind of got a second backup system. What I unfortunately don't have here in my arsenal of training aids is the spool that is supposed to function with a spool lock solenoid, but just to kind of show you how they would function. On a machine that had spool locks, there'd be an extra notch or groove cut into the spool, and that would line up with this solenoid operated device, basically just a coil of wire in here, and if these wires are powered up, solenoid pulls this pin out of the notch, and that notch is in a position that this would lock it in neutral. So if your Bics system failed, but you were somehow going to climb in the machine and step on the pedal linkage, or on pre-Bics machines, then this spool lock pin would fit into the notch, and that would latch the spool and lock it in the neutral position until the seat bar was down and press to operate was pushed. And these little pins, they say that they could withstand 750 pounds of weight on the mechanical linkage pedals before you break this pin. So a fairly strong pin. So I believe these solenoids were fed 12 volts, but I'm just going to use a 9-volt battery to actuate the solenoid here. So I'm just going to hook this up to a 9-volt battery. You can see that when it's powered up, that pin will pull out of the way. So there's power applied. Pin's just pulled back by, and then when I release the power, there's a spring in there that pushes the pin into the notch. So if the seat bar was up, or the press to operate switch hadn't been pushed, then there's no power delivered to this spool lock. And next time the spool slips through the neutral position, that pin would just pop into the detent, and until you put the seat bar down and hit press to operate, it would stay in that detent holding the spool in neutral. So that's a spool lock solenoid. It's not actually part of the Bics. It's a backup system for the Bics. And that's only on machines that have mechanical linkage operating the lift and tilt. On the machines that use a electromechanical spool actuator, you won't have the spool lock. Not necessary for a spool lock, because the actuator system for the spool is going to be your backup for safety. If the seat bar isn't down, or the press to operate button hasn't been pushed, well, then the ECM on the machine won't command any movement of this spool actuator. So again, you're going to find spool locks on machines that have mechanical linkage. So again, My valve here is built out of a mishmash of different parts of the spool. This is a Bics equipped valve. Either this spool, either this machine may have had electric spool actuators, but you'd still have the notch in the spool. So this is obviously older valve spools in a newer valve body. So back to the Bics valve again, Bobcat interlock control system valve. The handout's mentioning that there's 5 O-rings installed between the main valve body and the Bics manifold. 4 large O-rings, 1 smaller O-ring on the inlet. So I'm missing the 5th one here, but you can see the 4 large O-rings. They're sealing the work ports. This 5th port, where we've got a matching port here, again, I would need that O-ring in place for this to seal properly. But when the Bics valve installs there, that 5th port is the supply to the Bics system to make it operate. So the Bics is a hydraulically actuated valve. And again, it's going to have an electric influence. There's going to be a solenoid. Mine's missing the actual coil, but this electric solenoid fits over this stem. And that's going to be, again, energized at the same time as spool locks would be energized. If the seat bar is down, press to operate's pushed, an electric solenoid comes on here. It's just a 12-volt solenoid, and it actuates a hydraulic valve here. Kind of starting in the middle of the system, but oil's going to come up through where that 5th O-ring is and supply this solenoid valve. So there's the solenoid valve without the coil on it. It's got a screen where oil is going to supply it, and then in here is a solenoid actuated spool, and when it's pulled back by magnetism, by the electrically actuated coil, it lets oil go down and open 2 valves. These valves are called the Bics lock valves. We've got a lock valve in the lift function and a lock valve in the tilt function. So this is going to operate a couple of cartridge valves. But let's back up a sec, because between that supply port, the 5th port, and the Bics solenoid valve, we've got this component. So where oil comes up, it's main system oil that comes in here, feeds the main valve, and you can see where our relief is, perpendicular to that. Well, in that same cavity, that's where the feed is, up through this hole into the Bics system. And the first thing it encounters when it comes into the Bics valve is a screen, just keeping debris out of here. Because we got a solenoid operated valve, that's going to be an electromagnet when it comes on. Magnetism and, you know, fine flakes of fine particles of steel that might be, or iron or ferrous metal that might be in the hydraulic system, are a bad combination. So they're putting a screen here, fairly fine mesh screen, to try and keep debris out of the Bics system, because it's a safety system. And then behind that screen is a check valve. I'm just going to take this check valve apart so we can see the component itself. Okay, I've just got the check valve apart. So there's fairly light spring in there and a poppet, and they sit in the bore, and that fits into the housing like that. So that plug assembled goes in, just looks like a plug, but it's got this screen and check valve built into it. So oil comes in from the supply, and it's going to push the check valve off its seat, and then it's going to come out these radial holes into this passage, which is going to come over and feed the solenoid operated valve, or the Bics solenoid valve. So again, the path of oil flow from the supply comes up through that O-ring connection, through a screen, through the Bics check valve, then through an internal passage in the Bics manifold to the Bics solenoid valve, to another screen. And then if the Bics solenoid valve is on, oil will come out these radial holes and feed the 2 lock valves simultaneously. Now the lock valves are cartridge type valves. Just take those out here. So the two cartridge valves are identical and interchangeable. We just get some different versions of anodizing. The coating on here is different, but they are the same part number valve for the lift and for the tilt. And what these valves are hydraulically actuated. There's nothing electrical about these. They're going to move as a result of the Bics solenoid valve functioning, but they are hydraulically operated. Oil is going to come to the end of the cartridge here and push open a spool against a spring. There's a spring back in this end that's keeping the valve shut right now, but if I push on it, I can open that. So that's something I'm not going to stab myself with, and I'll just show you how much force it takes to open the Bics lock valve. So oil pressure takes about 100 psi of oil pressure to push that open. And when that spool pushes open, what it then does is allows oil to come and go from the work port that it's sitting next to. So this work port is for our tilt function. It's for the rod end of the tilt cylinder, or cylinders, depending on which model of machine we're on. And when that spring has locked that valve shut, oil can't come or go from this work port to the cylinders. So it has to get from this work port now through this slot in the valve and connect to the actual work port where the hose is connected. And it's not a straight through path. The work port itself, where the hose is going to be connected, or the T going to both hoses, is in between these sets of O-rings. The supply side underneath to that slot is in between these O-rings. So until that spool is pushed back out of the way, these two sets of holes are separate from each other. But once the Bics system comes on and this spool is pushed back by pressure, then that spool gets out of the way and allows oil to flow through between this series of holes and this series of holes. So oil can come up from the valve, through, and if oil is coming back, it can go through. So the oil going to and from the work port on the valve to the other side, work port on the other side of the Bics, has to take this kind of S pattern to get through or back. And again, if the seat bar isn't down, press to operate button hasn't been pushed, then there won't be any pressure here because the Bics solenoid valve won't have been energized. So these will be locked shut. Again, that's sort of our second level on top of spool locks that's going to hydraulically lock the oil, in this case in the rod end of the tilt cylinders. And then the other lock valve installs here, and it does the exact same type of blocking for the head end work port to the lift cylinders. Now it might kind of seem like you'd need to block both ports of a hydraulic cylinder to stop its motion, but in reality, if you block one port of a double acting cylinder, you've effectively blocked both, because oil's incompressible. If you don't let oil in or out of one side, you can't let it in or out of the other side. So there's one lock valve for lift. It's only in the base end work port. There's one lock valve for tilt, and it's only in the rod end. So again, those lock valves should never function because, again, they're just redundant with the spool locks or the spool actuator.